Okay, I want to introduce you to one more way to evaluate integrals called completing the square. We're going to use this when our integrand looks something like this, where we have an a squared, some kind of constant squared, plus our variable squared back here. And so this is a new arctangent integral that you can memorize, and likewise an arcsine on the right, in order to facilitate these questions. So the first one here, if we just identify what u and a are, so a squared is this first term, so my a is going to be root 5, because root 5 squared would give me 5, and that matches up with that a squared. So you can see u squared is back here, so in this case u is just x. So for the first problem, we're just going to plug into the formula. 1 over root 5 arctan of x over root 5 plus c. Okay, let's take a look at example 2. So example 2, likewise, it matches pretty much with the formula above. So in this case, our a squared is 16, so a is just 4. Our u squared is x squared, so u is just x. Then plugging into the formula, we have arcsine of just u over a plus c. Okay, let's go ahead and take a look at the next couple. So on these, we're going to actually have to complete the square in the denominator to get them to look like the formulas. So what I want to do first is, just like we did when you first completed the square in Algebra 2, I'm going to separate the constant and the variable, the constants and the variable. So I'm going to move that 13 to the back of the denominator, and I'm going to do a plus box and a minus box. How do we get the number in the box? Well, I'm going to take half of the 6, which is 3, and then square it. That gives me 9. So I'm adding 9 and subtracting 9 to the denominator. Okay, let's go ahead and simplify what we have. Or actually, let's write this. This is a perfect square trinomial. We're going to write that as a binomial squared. X plus 3 squared. Let's combine what we have left. We have 4 left over. So if we compare this to the formula at the top, we need to identify our u and our a. So let's just flip the order around. Order doesn't matter when you add. So 4 plus x plus 3 squared. So you see that this a is our a squared is 4. So a is just 2. Our u is going to be x plus 3. So let's just go back and apply the formula. So we have 1 over a, and then the arctangent of u over a plus c. 1 over a, actually let me use the space below. 1 over a, the arctangent of u over a, and then plus c. So when do we use this? We use this when we do not have a bigger power in the numerator or an equal power in the numerator. Because if that was true, we could do long division of integrals. We also use this when we can't just separate it into multiple fractions. We can only do that if there's a single term on the bottom. And u sub doesn't work. If I try to make u equal to the denominator, du would not be available in the integral. Okay, let's try another one. So rewriting the denominator, the plus box, minus box, plus 7. Okay, half of the 4 is 2. 2 squared is 4. The number in the box is always positive, so I don't need to worry about the sign. Okay, so I'm going to rewrite the first 3 terms there as x plus 2 squared. Oops, sorry. X minus 2 squared. And then back here I have a 3. So again, if you wish to switch the order, so 3 plus x minus 2 squared in the denominator. So our a this time is going to be root 3, and our u is going to be x minus 2. So integrating 1 over root 3, arc, tangent again, x minus 2 over root 3, and then plus c. Okay, let's try one more together. I foresee that this will be an arc sine problem. Okay, so let's go ahead and I'm going to maybe under that radical factor a negative out before I complete the square. So x squared minus 4x, and then I'm going to do a plus box, minus box. That's all under the radical, I believe. I think that I did that correctly. Yeah. I just switched the order and factored out a negative and then did my plus and minus box. So again, half of 4 is 2. 2 squared gives me 4. So put a 4 in each of those boxes. So let's evaluate what we have. So inside the integral, I'm still going to go ahead and write that as a binomial squared. So that's going to be x minus 2 squared. And then let's see, this 4 has what sign? Well, it's negative. Is it times this negative here? It is times that negative. So that's a plus 4. So in the denominator, I have the square root of 4 minus x, the quantity x minus 2 squared. Okay, so I think we probably can identify our a is 2 and our u is the x minus 2. So let's refer back to our formula. So let's compare. Okay, I think we are correct. And our antiderivative is just going to be arc sine of u over a plus c. Arc sine of u over a plus c. How can we check these? You can check these by differentiating. You'll have to do some algebraic manipulation to make it equal the original problem, but it can be done that way. You could take the derivative of this and do some algebra, and you would end up with the original problem.